A woman had been buried side by side. Their bodies were carefully positioned. Their remains suggested they had not simply been placed there at random. Someone had taken time to arrange them together, as if their connection mattered even after death. At first glance, it seemed romantic. But then scientists asked a difficult question. Was this actually love? Or were we projecting modern emotions onto people who lived in a completely different world? The mystery became even deeper when researchers began looking further back in time. Much further. Because if humans today write songs about love, build monuments for love, start wars over love, and spend entire lives searching for love, when did it all begin? At what point in human history did two ancient humans first look at each other and feel something more than survival? The answer might seem obvious. Surely love appeared when humans became human. But there was a problem. The evidence didn't fit. For most of human history, survival was brutally difficult. Every day was a battle against hunger, against predators, against disease, against freezing temperatures, against rival groups. A single mistake could mean death. In that kind of world, emotions that did not help survival should have disappeared quickly. Natural selection is ruthless. Anything that wastes energy tends to vanish. And yet love survived. Not only survived, it became one of the most powerful forces in human existence. And that's where things get strange. When scientists began studying our closest living relatives, chimpanzees, bonobos, and gorillas, they discovered hints of something unexpected. Chimpanzees form friendships. Bonobos develop long-term social bonds. Gorillas can remain attached to specific partners for years. These animals do not write poetry. They do not exchange gifts on anniversaries. But they clearly experience social attachments that go beyond simple reproduction. This raised a new mystery. If our ape relatives already possess the building blocks of emotional attachment, then perhaps love was far older than humanity itself. Perhaps the roots of romance stretched millions of years into the past. Researchers turned their attention to some of the earliest known human ancestors, creatures like Australopithecus, small-bodied hominins who walked across African landscapes more than 3 million years ago. Their world was dangerous. Lions hunted the grasslands. Leopards waited in trees. Massive crocodiles patrolled rivers. Food was never guaranteed. Every day demanded constant vigilance. The obvious assumption was that relationships would have been short and practical. Finamade, produce offspring, move on, simple, efficient. But then scientists noticed something that challenged this idea. Ancient human children were unusually helpless, far more helpless than the babies of most other mammals. A newborn foal can stand within hours. A young chimpanzee becomes relatively independent, much faster than a human child. But human offspring required years of protection, years of feeding, years of teaching, years of care. And that created an enormous survival problem. How could a mother gather food, avoid predators, and protect a vulnerable child for so long completely on her own? The answer seemed obvious. She couldn't. But if one parent wasn't enough, who helped? And could that need for cooperation have accidentally created something that would eventually become one of the most powerful emotions in human history? For decades, anthropologists searched for clues. The challenge was obvious. Love does not fossilize. You cannot dig up a heart-shaped stone and prove two ancient humans were romantically attached. You cannot measure affection from a skeleton. At least, that was the assumption. Then researchers began noticing patterns hidden within ancient bones, patterns that suggested something surprising. Some prehistoric individuals survived injuries that should have killed them. Broken legs, crushed ribs, severe disabilities, diseases that lasted for years. One famous example came from a much later human relative known as Neanderthal. Several skeletons showed evidence of catastrophic injuries. Some individuals had lost the use of limbs. Others suffered major trauma that would have prevented hunting. Yet they survived for years afterward. That meant somebody had fed them, protected them, stayed with them. The fact was remarkable. The consequence was even more important. In a world where every calorie mattered, caring for another person carried a cost. Food given to an injured individual could not be eaten by the caregiver. Time spent helping someone weakened your own chances of survival. Yet ancient humans repeatedly made that sacrifice. Why? The answer seems simple. Family. Relatives often help one another because they share genes. Helping a brother, sister, or child can indirectly help your own genetic future. For a while, many scientists believed this explained everything. But then the evidence didn't fit. Some archaeological sites suggested care extended beyond immediate family. Individuals appeared to receive long-term support from entire groups. And that created a new mystery. Why would unrelated people invest precious resources in someone who could no longer contribute? The answer may lie in one of the most important developments in human evolution. Humans did not become successful because we were the strongest. We were not the fastest. We did not have claws. We did not have fangs. What we had was cooperation. And cooperation works best when individuals form strong emotional bonds. Trust increases survival. Loyalty increases survival. Attachment increases survival. Gradually, researchers began to suspect that what we call love may have evolved from a much older survival system, not a poetic feeling, not romance, a biological strategy. Imagine a pair of early humans living on the African savanna 2 million years ago. The dry season arrives. Food becomes scarce. Predators become bolder. A mother carries an infant who cannot walk. Alone, her chances are poor. But if a male remains nearby, bringing food, warning of danger, and helping defend the child, the infant's odds improve dramatically. The child survives. The parents pass on their genes. Over thousands of generations, natural selection would favor individuals who stayed together longer. Not because love was beautiful, because love worked. And that's where scientists discovered something unexpected. Modern neuroscience reveals that romantic attachment activates ancient chemical systems deep within the brain. Oxytocin, dopamine, vasopressin. These chemicals create feelings of trust, reward, and emotional connection. What's fascinating is that versions of these systems are found throughout the animal kingdom. The machinery itself is ancient, far older than modern humans, far older than civilization, perhaps even older than the genus Homo. But there was a problem. If pair bonding helped raise children, why do humans experience such intense emotions? Why jealousy? Why heartbreak? Why longing? Why the overwhelming feeling that one specific person matters more than everyone else? These emotions seem far stronger than simple cooperation. The answer seems